from my point of view, I see myself as a facilitator in this process, but I'm happy about this result. I think we have some interesting inputs here. After I propose to take a look to these, if somebody would like to add something by voice to explain better his own proposal, can be nice. Otherwise, I suggest to go ahead with an analysis from your side as an expert of this. But I think we can ask to the people first of all if somebody would like to add something.
Let's see if someone breaks the ice. So otherwise, I can try to break the ice. So regarding which kind of data, of course, pollutants are the primary ones. One consideration could be, from my point of view, the second data mentioned here, the number of people inside the building that is, of course, changing. So while pollutants measurements of so quantities of pollutants are measured through sensors as planned in our project, in EDIAQI project. Number of people inside buildings, not in all cases, can be measured in a dynamic way, so through sensors. So we need to focus a little bit on the meaning of this second data set. And so I think that both the number of people and air conditioning time schedule can be can be offered and can be provided as average static information in almost cases, or in the majority of cases. Of course, the ideal situation could be to have also for these data sets, for this kind of information, real-time dynamic data coming from sensors. Ancillary data, weather conditions, room exposition, outside pollutants. This is, I think, very interesting because, well, let's start from rooms exposition. If we rely on geographical data, so if we consider the location of the building, the topology of the building, in terms of geographical information, this can be automatically derived. So we know if a room where a sensor station is installed is exposed to north, south, east, or west, but also the external context, if there are some barriers, other buildings, vegetations, or trees. And while weather conditions or outside pollutants, I think are very interesting because these data are in almost all cases already available in an automatic way. So it is feasible to get for almost all pilots and also beyond the EDIAQI project pilot areas, dynamic information about weather conditions and outdoor air quality conditions from APIs, and for air quality, outdoor air quality. I remember that there is a standard-based API provided by the Fraunhofer Institute with the dynamic data coming from the European Environmental Agency for all air quality monitoring station in Europe. Well, regarding infographics, let's have a look in more detail. Data is a stripe column for each observed parameter. To me is interesting. I think that here we are still missing a little bit what you mentioned in the first part. So who is the target users? So the target user, or who are the target users? And depending on the categories of users, we may consider a presentation format or another.
Maybe Giorgio, is depends also from my input in order to reach this to gather this data. We are here. We don't mention a precise. We don't have mentioned a precise target. We talk about the audience in general, but not in this request for information. So we have here some input. We can decide where and in which cases maybe is more adapted to a precise target or to another one.
Yeah. So I think that we might, in the following days and weeks within EDIAQI project, we might start from this input, in particular related to infographics, to further explore and expand each of these boxes. And this, I think, in my opinion, is also tightly coupled with some inputs provided in the right column in blue. Yeah, because we need to, within the storytelling approach, we need always to provide a narrative, some narrative to describe data themselves, so to describe the situation, but also to explain, like suggested here in almost all of the four blue boxes. We need to describe what's behind, for instance, an index or a type of measurement, so how measurements are taken in order to be understandable to non-experts. So I see the second column, so the comments and suggestions of the second columns very tightly coupled with the blue ones. I think that it is a good start for us for next weeks.
So if you agree, I can close the poll. And I will stop also my screen sharing.
Okay.
This data will be available.
Okay.
Okay. So I will close here and I will stop.
Okay, thanks. So I will leave the floor to Beatrice. Beatrice will briefly present a plugin that was developed last year by a colleague of ours in Deda Next using Python language to enhance QGIS software that is an open source GIS solution, so a geographic information system. I leave the floor to Beatrice, that will also introduce what QGIS is and drive us to on how to get download, install not only QGIS but also the plugin itself, and will showcase how to use the plugin. The floor is yours, Beatrice.
Thank you. So hi, everybody. As Pier Giorgio was saying, I'm going to talk about the QGIS plugin that we built in Deda Next. So let's start. First of all, I wanted to take a step back and look at the architecture that we have talked about so far. So we start from our IoT data, and then we use Apache NiFi to build ETL flows. So we transform that data and we transform them so that they are they can adhere to the standard, which is SensorThings API. And then once they are transformed, we can put them inside our Frost structure. What we have seen so far, like in the previous episodes of EDIAQI, is that we can then expose that data through an endpoint. So even Luca before was talking about examples of this endpoint. But the thing is that, for instance, here I put a link to the endpoint of the Fraunhofer Institute. So they created this endpoint to show air quality data around Europe. But what happens if I click on this link? Well, this happens. At least this happened to me because I use Google Chrome. So if you have Google Chrome, for instance, you will see this data. And I mean, if you are a developer, you can use that data. You can make visualization starting from this. Maybe if you're not, it looks a bit ugly to you. If you are a bit luckier and maybe you have, let's say, Firefox as your default browser. I'm saying Firefox because it has a built-in beautifier for JSON. And so maybe you will see something like this, which is more readable, but again, still not very useful because you cannot really see the trends, the patterns inside the data. So how do we visualize data from Frost, and how, if we are not very if we don't, I mean, we are not developers, or we don't want to build create a dashboard or something? Well, I will tell you more about this. So about Frost data visualization. First of all, I would just want to say shortly something about GeoNext, because GeoNext is our geoportal. We created it's Deda Next geoportal. So we have a built-in function to to display Frost data inside our GeoNext. I will go quickly through this, but as you can see, we can display the data that are inside our Frost database. Here, for example, we have the air quality data in Ferrara. If you click on the data, you can see the different pollutants. Then you can click on the single pollutant and see the values over time. But this is not our focus. Our focus is our plugin QGIS. Why we decided to create a plugin in QGIS? Well, first of all, let's say what QGIS is, because maybe some of you don't know. So if you are a bit into geospatial data, you will know that GIS stands for Geographic Information System. So NQ stands in this case for quantum. So what is QGIS? QGIS is a platform that you can have on your desktop. It's a GIS application, and basically what it does is it allows you to interact with geospatial data. Namely, you can view, edit, print, and analyze that data. So, but the real good thing about QGIS is that it is free and it is open source, which is not the same for all the GIS tools. So this is mainly why we decided to create a plugin inside this platform, because so everybody can use it. Here, I put some GIF to show you how QGIS works. So as you can see, you have this this screen where you have on the left the layers. And you can basically add new layers, you can hide them, you can change view order, so one is over the other. Then, for instance, you can select different polygons, as in this case, or you can make operations like intersections of different geometries and so on. And finally, here I put an example of like some interactive data visualization that you can create. For instance, here we can see data changing throughout the years. Okay, so like if I made you curious enough, now you maybe want to download the QGIS. How would you do that? Well, I put you the link inside the platform. If you click on the link, basically you will go on this website, which is this one. It's super easy, like you will just have to follow the instructions. So you click on the download button, and I think it's easy, so you can do it. And once you have QGIS and you open it, this is what you will see. So if not, like you just have to click on new project. So you will see a white sheet, and on the left you have like the options and the layers. So for instance, one very easy thing that you will have to do, like probably the first one, is you will have to add a map. So we have different providers. For instance, we can put the OSM standard map, and so you can know where you are. So for instance, I will zoom on Europe. So we have like a base map to work on. Then I'm sorry, because my QGIS is in Italian, so maybe it's not super easy for you to understand, but I will try to explain everything. You can, for instance, add new layers coming in different formats, for instance, CSV, shapefiles, and so on. We even have options to use WMS or WFS. So, for instance, I can show you in this case, I have like as an example a WMS of the Bologna, which is a city in Italy, where we created 15 minutes city index. It's not like related to this project, but it's good to see that we have also this option. And then I can, for instance, I don't want to see this anymore. I will hide it, but it's still in my layers. Okay, so now that I think you can understand a bit better how QGIS works, we can see what is the plugin. So the plugin that we have here is basically is an added function to visualize inside here our frost data. How do we download it? Here I gave you the link. So if you open the link, you will go here. You will just have to download the latest version of the plugin. So you click on download, and then you will have it in your, you will download a zip and you will have it in your downloads. So on QGIS, to have it, you will have to go on plugins, and then something like install plugins. You will have this window, and you will have to go on install from zip, and then you will choose your file and click on install. And just as simple as this, you will have like two new buttons will appear. So you will have this left one with the bubbles, let's say, which allows you to upload the endpoints. And this second one, which will allow you to interact with the data. So let's see what happens, like if I click on the left one. So let's say we want to, well, let's see, maybe we can do this. Okay, so when you open it, you will have it blank, and you will be able to upload a new one. So there will be probably new in English. And for instance, let's say as an example, we will use the municipality of Ferrara. And to do so, we will need the URL of the municipality of Ferrara, so the endpoint. You can find different examples of endpoints in the other link that I put on the presentation. So here, for instance, the first one is Comune di Ferrara, so we can copy. Okay. And paste it here on the URL. As you can see, the location, the link here is the endpoint plus /locations. So what we are visualizing here are the locations. I will put OK, and now we'll put connect. I will press connect. Okay, so before diving into this, I want to say something about what I said before. So locations. Maybe you don't remember, but I want to fresh up your mind, your memory. So we have, this is the data model that we have in Frost. As you remember, like the core are the observations, which are the actual values, so the actual data. And each observation is connected to a location. So of course, we are on geographical geographical data tool, so we are using the geography, so we are using the locations. In particular, we will focus now on one of the field of location, which is properties. So the thing is, inside the Frost database, we can have many data coming from different projects and different parts of Europe, and so how do we diversify them? Because maybe we don't want to upload all the data that we have inside our Frost. Maybe we just want to upload some data which are related to one project. So to diversify them, we decided to use the field property and add the name of the project. So let's say, for instance, here we only want the data from the air quality lab service, which is a project that we did with lab service, which is our provider of air quality stations. So if we want only to upload this data, we can do it. And that's because we added, as inside the property field, we added the name of the project. So basically, when you create the Frost structure, you add this, you add information inside the properties, and then the plugin will show you the different groups. So for instance, let's say we want to see this data. We will click on them, on this row, and we will click on add. Now, okay, this data, of course, are in Ferrara, because we are in the municipality of Ferrara. Okay, maybe let's change the color so you can see them better. Okay. So you see, these are the locations of the stations of air quality installed by lab service. Now that we can see them, we can click on them so we can interact with the data. Let's see what happens. So for instance, I pick this one. Okay, so as you can see, we have like up here, we have the name of the station. We have like some more information like the code, the project, and so on. But very important stuff is here. So again, sorry, it's in Italian, but here you have the pollutants, the description of the pollutant, and then we have the the start date and the end date of data. So for instance, you can see that these are available starting from September 2021, and we are still collecting the data. Indeed, they are like the latest one is from 29th of September. And then that's not it, of course. We can go and check the data. So here we have a table. We can decide the period of time in which we want the data. So let's say, for instance, we want them from yesterday to today. So the last 2 days of CEO data. So we can press on update. And here we will have all the data we need. We can even download the data by pressing here, and we will get a CSV. But I mean, still, like, this is very useful, but still, like, we are not seeing any trend or any pattern. So what is really cool about this is that we can even show data in a graph. So here you have this interactive graph. You can see the time, the value, the trend, the pattern. So you even have this option. And this is the same for all the observation of the observed properties that you have. So here, for instance, we even have the temperature. We have the graph of the temperature. You can change the day. So go back 1 week. And okay, so you see even the trend during the days of the temperature as we expect. Okay, so now like I can make another example for you, which I think is very relevant. So again, I want to show you the Fraunhofer Institute data. Again, you can find the endpoint here. This is the second one. Remember that there is location. So I already have it, so I don't have to add it. I just simply choose it from my list and I connect. So this takes a bit more of time because they have data from all around Europe. This is a more complex structure, and that's because we have more data. So, but again, like the field that we use to diversify the data is the field property. Here, for instance, but the difference with like the previous example is that previously the only grouping we did was based on the project. Here we have different options. So for instance, we can decide to filter, oh, sorry. I clicked and it added. So we can decide to filter filter on the owner, on the metadata, on the country code. So for instance, let's say we want to filter on based on the country code. Okay, we only leave country code here. And here we have the code of the countries. So for instance, let's say we want to do, I don't know, Italy, since I always work on Italy, so I know better about its geography. Okay, so now if we add Italy, you will see that we have all the stations from Italy that are from, in this case, related to air quality in Italy, and they come from official stations of Italy. So again, you can go on one of these, you can click, and you will have the same information. Of course, like these, like the things that are written here change a bit based on how the provider decided to store the data. But again, here you can see we have NO2, we have NOx, O3, and so on. And so you can go on the observations, you can see the graphs, and you can always do this as long as you have a frost structure behind this.
Sorry,
okay, fine.
Beatrice, sorry. If you try also to load Austria one, because if I remember correctly, in the case of Austria, data are almost real time. That means that we should be able to see air quality data updated at 11 o'clock, so half an hour ago. Just try to click somewhere, yeah.
Salzburg. Yeah, so indeed, let's see. Yeah, the last one is 11. Yeah, so like from 10 to 11. Yeah, this, like, of course, we can have real-time data depending on how, what is the delay with which the stations send us the data. But as long as we have the data, we can do it like right now. Yeah, so it's really nice to know. And yeah, I can actually try to upload all Europe, but I don't think it's gonna take too long. And you'll see, or maybe my QGIS will get killed. I don't know. But yeah, you can upload all the data. Let's see.
Yeah, it just takes a few seconds more, but
yeah, I mean,
it works.
Yeah, it works. It's like you can see them here. Yeah, all colored and nice and. Okay, so yeah, you can basically like do the same everywhere. Yeah, and I think I covered everything actually. Maybe if you have any question. I don't know.
I don't know if there aren't any questions related to the functionalities of this plugin. I just want to highlight and stress the fact that this could be just an example of an implementation based on a quite common programming language like Python. In this case, applied to a GIS software, but the same could be done on other typologies of software. We decided to add the functionality to QGIS for two main reasons. On one hand, because of our love for geographical information. So we are almost always used to think in terms of geographical information or geolocated information. On the other side, because there's an emerging and even always more important aspect related to the need for connecting geographic information, static geographic information to IoT and sensor derived data. So it is important to have GIS software, starting from open source GIS software, also enabled and able to access sensor data, but relying on standard endpoints. So to exploit the full capability of standards like SensorThings that offer the complete set of possible requests, therefore set of functionalities, not only for visualizing, but also for accessing in terms of downloading data. What Beatrice showed was just a set of examples of steps that can be applied to different domains, included air quality data, and more in particular applied to indoor air quality data. In this case, for indoor air quality data, we need also to consider another aspect, that is the location of monitoring stations that can be installed in the same building, so in the same location in terms of 2 dimension, but in different rooms of the same buildings. So we need to have a much more detailed representation of the geography in terms of buildings and in terms of building components and building parts. I ask maybe to Marcello, Lorenz, or even Alessandro from Lab Service, or Michael, if you have any curiosity, any questions. Just don't be shy. Alessandro, hi.
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 I don't have some curiosity. I know very well your precious work and what we have done. Will it be the same for the EDIAQI project? So I understand that we will have the same in the project for sharing and watching the data trends in the next month.
Yeah. Again, so in EDIAQI project, we are already said that we need to share data through an interoperable standard interface represented by SensorThings. We need, like said before, we need to think of which kind of technical users, so specific categories of users may access dynamic data by connecting through SensorThings API endpoints. And there are different possibilities. Today, we wanted to stress the fact that this can be done not only through web applications that have some characteristics, but also by thinking of desktop-based applications. And QGIS is just one of the possibility. It is not the only possibility. What we saw with Beatrice is a plugin that at the moment is tagged as an experimental plugin. That means that it is not yet, it is already available in the repository of plugins of QGIS, but is going to be further evolved. And we are already working on that beyond and outside the boundary of EDIAQI project, together with the National Geological Institute of France, BRGM, that asked us, together with another Italian company, to make the plugin a little bit more robust and split the functionalities in two main parts. So the main functionality that is the functionality for accessing remote endpoints, like the Fraunhofer one that we saw, or the possible new upcoming endpoints by EDIAQI pilot areas. So the functionality for accessing will be embedded in the core of QGIS. So that means that once in a future release of QGIS, once a user will download a future release of the basic QGIS platform, we'll have already the functionality for accessing remote standard SensorThings endpoints without the need for downloading the plugin. An external plugin will remain and will be, of course, provided in the official repository of plugins of QGIS for more advanced functionalities. For instance, at the moment, the plugin is limited on purpose, was limited on purpose on starting from the request of location. Okay, as we saw during the presentation done by Beatrice, the URL that was configured was having as a suffix /locations. That means that it is strictly needed to start from that type of request in terms of SensorThings API request. What we would like to do in the next months is to consider also other types of requests that are already offered by SensorThings API. So not strictly depend on starting from requesting the locations. The request of location will remain, of course, because of QGIS is basically it is based on a representation of locations. Another change that was asked by BRGM was to think of possible data analytics. Data analytics means that at the moment, for the time being, with this version of the plugin, you are forced to click on a single location, select a single parameter, and download the data of a specific temporal extent.
Yes, of course.
Okay. For data analytics, we are thinking of having the possibility to present, for instance, in a fast way, thematic maps, so points representing locations already symbolizing, already visualizing, for instance, the last value of that specific parameter or the average value of a certain temporal extent, without having the need for interacting with each individual location and with each individual parameter. Okay, so the idea is to further evolve this plugin by adding somehow further functionalities, but these should be seen and should be considered as a set of functionalities more for technicians, more for a specific set of users that need to have a more interactive way to play with data.
Yeah. Okay, indeed. Thanks, Pietro. What we are looking out basically with your slides and presentation is also a way to have fair data access that is in compliance with what we wrote in the project and what we are doing. So also for the WP7 part and for the communication side, I will advise to Alex and to who he is in charge to do that, to have also a specific web page in our site in order to give info on how people can get data in an easy and fast way.
Yes, exactly. Within another project, we are running in parallel another Horizon Europe project where also the municipality of Ferrara is involved as a partner. We have this explicit goal for providing dynamic data. In this case, dynamic data coming from the SensorThings endpoint of the municipality of Ferrara into the open data portal of the municipality. So these two reply to your to your comment when we are talking about data that need to circulate. Also, in the case of EDIAQI project, there is an ambitious goal of providing some of the data that will be collected, not all of us, but for sure dynamic data regarding observations, measurements of indoor air quality, following the so-called FAIR principles. I remind that FAIR is an acronym that stands for findable, accessible, interoperable, and reusable. In the case of EDIAQI, we don't have as a target, as a deliverable of the project, the goal of implementing a web accessible catalog where to provide data and metadata with open license, but we are working on that in this parallel project I was mentioning. So the idea is to tightly couple software components like Frost, that is implementing SensorThings specification on one side, and on the other software components like SICAN Open Data Portal. That is SICAN is another open source solution widely used worldwide for implementing open data portals based on other types of specification for metadata, and creating a link between them means to offer the possibility to general users looking at and searching for dynamic data in some open data portals to access to have a view and also the possibility to download this data by connecting a SICAN portal with a Frost component. Okay, and I think that this could be an ancillary option also for a EDIAQI project, even though not explicitly required by the EDIAQI project itself.
Yes, of course. Thanks, Pier Giorgio, for your
thanks to you
comments.
I don't know if Marcello or others wants to add some comments. Otherwise, well, we have Marcello.
No, I don't have a particular comment.
Okay. I just saw that you switched on your microphone, so I suppose to. So we have some more minutes. We can finish, of course, the webinar in advance, so before the planned time. We could jump to the conclusion of these webinars that are also an anticipation of what we will have in our final webinar next month. So let me share my screen. Can you see it?
Yes.
Okay, so a very, very brief and fast recap of today. We introduced the topic of data visualization because, like many other projects, also in EDIAQI project, we will work on how to present data to different types and categories of users, and we started to see some examples implemented using web-based application through JavaScript libraries explained by Luca, with different examples also focusing on outdoor air quality data. Marcello introduced the need for also for focusing on data storytelling, so not only considering graphical elements like maps, charts, and other similar components, but also considering the need for describe in a narrative way the context and also the content of data provided through graphical representations. Beatrice gave us a very fast but deep list of how-to for the Python-based plugin implemented for QGIS software. And let me just remind that the purpose was and is to present some examples of implementations that can be further extended, not only considering as a base software a GIS tool like QGIS, but also other types of desktop software. In this case, QGIS was presented because of the importance of presenting dynamic data about air quality, starting from the location of monitoring stations. So as mentioned here, on October 27th, we will have our next and final webinar. And the focus of this next session will be on data models for buildings properties. This actually, I will update this slide. The data is not proposed. It is definitive. It is already agreed, and we will start on what already anticipated in our first webinar. There is a directive, a European directive that is called Inspire, that also for buildings, so for data related to properties of buildings, already provides some data models. Data models, that means a list of attributes, a list of elements that are already well defined by regulations that are following the Inspire directive. And regulation means that there are some elements that are already mandatory, for instance, for public administrations, for sharing the data about buildings with their attributes, with their properties, and so on. And then there are more technical data specification, more technical guidelines that are already providing a lot of useful and detailed information about how to model buildings like the ones that we are going to consider in EDIAQI project. I'm referring to pilot buildings of all pilots of the EDIAQI project. Behind the Inspire data specification of buildings, there is again a OGC standard that is called CTGML that was published some years ago for allowing modeling different types of urban level objects, not only buildings, but in particular buildings, a different level of details. And here we see the different level of details considered by CTGML. So if we look at the final row, the so-called level of detail 3, we can see that the CTGML already offers us the possibility to go very in depth, considering specific elements of the buildings, not only construction elements like windows, doors, openings, and so on, but also one of the main class of the CTGML data model for buildings is represented by building parts. That means that we can have data representing not only the whole buildings, but the subdivisions of buildings in terms of rooms, floors, and so on. This is important because, as we know, in the case of EDIAQI project, we will have in the different pilot areas, pilot buildings where sensors will be installed in different rooms at different floors. And so we need a more detailed level of for representing the location, not only two-dimensional points like the examples that we saw this morning, thanks to Luca and Beatrice, but we need to represent the location of the sensors, so the things equipped with different types of sensors, with a more advanced and detailed level of representation. That doesn't mean necessarily to have 3D graphical representations like Google Earth or like other software like Cesium.js that allows us to browse in a three-dimensional way geographical objects. But data behind, even though navigated and browsed with two-dimensional maps, have to be modeled considering different floors, different heights of rooms and building components. Why CityGML? Because the last version of CityGML standard that was introduced a few years ago have a module, a specific module called the Dynamizer that was defined by different OGC members, in particular universities and also other partners of OGC coming from Germany, to integrate dynamic data coming from IoT devices and sensors. And so the CityGML could be interesting for thinking on one side to present in a more detailed way where the location of sensors, so of indoor air quality stations of EDIAQI project are, but also for linking these static data about the location of sensors, so the inside room, the indoor building parts, with SensorThings endpoint, as written here in the open document of the CityGML specification. This module called the Dynamizer has three main purposes, and the first one is to allow to retrieve observations directly from external sensor and IoT services using a specific class of this module, and by connecting to standard endpoints based on SensorThings APIs. So that means that we have the possibility to work in parallel on two different types of standards. On one side for dynamic data, SensorThings API, on the other one for more static properties of buildings, the CityGML. And let me anticipate that on October the 27th, we will have a quite detailed and full presentation by Dr. Giorgio Argugiaro, that is an assistant professor at the TU Delft. Giorgio worked a lot on CityGML, and in particular, he was involved some years ago in a working group dealing with an application domain extension of CityGML, so an extension of the standard CityGML for introducing new classes, new modules. And thanks to his work together with other participants of this working group, this new module called Dynamizers was introduced in the version 3 of the CityGML. So on October the 27th, we will focus on something that is not related directly to observations and measurements of indoor air quality, so not dealing with dynamic data from sensors, but is somehow indirectly related, because as mentioned here, this module of the new version of the CityGML offers the possibility to connect 3D models of buildings and building parts on one side, and time series of dynamic data on the other, coming from, of course, SensorThings APIs. So I don't know if there aren't any questions. I remind you the date, Friday, October the 27th. And if there are any further comments or questions, I can stop sharing my screen, and we can close the webinar. We can quit the webinar a little bit in advance, but I think that is okay for